Hi, good evening. Um, so I know the test was supposed to be this week. Is that still happening? Okay, next week then?
Probably next week.
Okay, is there a certain day that you'll be taking it, or is it like you get the full week to take it?
You'll have a whole week to take it. Already panicking. You haven't seen the test yet. Happy Tuesday. We're going to continue our study of integration techniques. For the most part, the hard stuff is done. Basically downhill from here. And it's a good thing. So you survived this long, so you should be fine. Today is our last technique for antiderivatives. And it's possibly my favorite. Reading a table or using a calculator. Going to start with the calculator option. Because why not? Oops, I did not mean to close you. I will show you once the TI Inspire, and then the rest is going to be Mathematica. If it's the 89, it's going to be very similar.
Yeah, I have the 89.
Two options.
With my calculator actually dead right?
It is being recorded. Two options. You can either type in integral using your keypad. Then just type in the function. So our function was 1 divided by, right? And be careful with parentheses. X times square root, again, two options. Just type in SQRT, right? Or you can actually just use the square root. Doesn't matter, give you the same thing. All right, so there's our function, comma. You now need to tell it with respect to what variable? X. There's your antiderivative. Notice it does not give you the constant. Right, so you'd have to include that. Won't let me paste it as a picture. That's annoying. Which means I'm going to have to do it this way. Oh, wait. You down there, and then do screen capture. Oh, right. Yeah, why not? That's good. Okay. Mathematica is very similar. Command is integrate. Oh, wait. I forget. The other option is to go to menu, calculus, and then integral. It's an antiderivative. You can just ignore the limits. So just be 1 over x times square root x. Back to x and enter. Uh-oh. Supposed to be 1 minus x. Same thing. Again, need to enter the function. This one would not be partial fractions. And so again, be careful with parentheses. And then with respect to x, all right? Mathematica commands are always started with a capital letter. Notice what happens if you don't type in a capital letter. Notice the text is blue. That means it's going to define this as a variable, not a command. All right, and it's always braces, not parentheses. Then to execute, just hit Shift Enter. All right, now, this is not a form we want. Right, because we're not studying the hyperbolic functions. This is an inverse hyperbolic tangent. I'm going to click more, convert to exponential. Yes, Mathematica uses log as the natural.
Same thing,
Not the same.
like log 10.
No, log 10 and natural log are completely different.
Okay, I kind of feel.
But it always uses natural log. It'll specify if it's a different base.
Just go back like 2 seconds. To see how it makes. Thanks.
This technique is much easier. So integrate, we want the function. On over, use parentheses. X to the 1/2 minus X to the 1/4. And then with respect to what, X. Whatever, that's good enough. Now, technically speaking, these answers are not entirely correct.
I'm gonna say that doesn't look like what my calculator gave me, and I put it into.
Well, it may give you something different. Notice that the Inspire gave us absolute values. Mathematica doesn't. Right. So I'm assuming the reason it didn't give an absolute value here is because they're saying this will never be negative. I don't know how they can know that, but apparently it does. I would just be safe and just write down absolute values. There you go. One over x times square root x squared is x plus 2. X. See what it gives us. Oh dear, I don't like that. I just want to try something. This should theoretically work. Simplify to exponential. Now I should just be able to put a percentage in there. Ha! It did. Sometimes that doesn't work. I don't know why. Right, the percent is just going to recall its last output. And again, remember that Mathematica is using log to represent the natural log. Right, that is not log base 10. Just. But it doesn't keep the size, of course it doesn't. Bless you.
Thank you.
Impressive. On the TI, I'm not getting the absolute value for the second log function. Should I still put that in my answer?
I would be safe and put it in anyway. And if it's not giving you an absolute value, it's reading it as it's never going to be negative, which is why it doesn't need it. Did I? Hmm. This is. Yes. All right, so function x over the quantity 5 minus 4x minus x squared raised to the 3/2 power with respect to x. This is why this is my favorite technique.
Is there a way to get a different form of the same answer on the calculator? Because I got something way different.
Yeah, you don't get the so.
You can try the simplify command, which is typically under the algebra menu. Bless you. Which is why I will require screenshots of your calculator. Oh, technology, why do you do this to me? treat you so well, and you just want to stab me in the back. Oh, well, that's nice. You just pasted a very tiny ass picture. Okay. One plus. All right, so sine of x minus cosine of x. And again, pay attention to how they're being inputted. I wonder. Now it doesn't want to simplify that. Okay. I could convert it to exponential form, which looks really hideous, so you don't want to do that. And that's just for fun. So we'll just go with that. Do this. Actually did make that a little bit better. And so integrate, we want 1 over 3 minus 2 cosine of x with respect to x. And let's see what this gives us. Fun. 1 over 2 plus cosine of x with respect to x.
The previous one, my calculator, in addition to like the answer up there, in the numerator, it has minus mod of x minus pi, comma, 2 times pi plus x.
It's probably because it's accounting for the periodicity of tangent.
But I write that then, is that considered part of the integral?
No, you can ignore the mod stuff. That's not necessary. Lush. Let's do something a little bit different. Go to wolframalpha.com. I'm actually gonna go ahead and sign in. No, of course you're gonna send me a prompt. There's also a Wolfram Alpha app. I think it was like $3, something like that. It was like the best $3 I've ever spent. Because it is essentially this entire website on your phone. It was like the best $3 I've ever spent. Wolfram Alpha, you can use, for the most part, the same commands as Mathematica, but it also recognizes like common text. So I can just do integral and say of, and then what was the function? It was 1 over 5 plus 4 sine x. See if it does that without me having to tell it with respect to x. It does. Right, and then that is your solution. I believe that'll work if I just do copy image and then paste, and there we go. And look, this one even tells us plus a constant. That's nice. That is through the use of technology. I've now uploaded the integral table. Of course, you have to zoom in, right? Because there we go, window width. So you have some basic integrals. Right. So for this first upcoming test, those basic integrals, you're allowed to use regardless. On the trigonometric integrals, I will allow you to use those 6 reduction formulas as well for any problem. That's it. Unless the problem specifically says use a table. For the first test, you're not allowed to use the table except for what I just mentioned. When using a table, it is very important that you make note of the formula that you're using. Right, so if you use, for instance, formula number 27, mark it that you're using number 27. This way I can cross-check the table and make sure that you did it right.
You know, we're using this on my canvas.
This is on Teams,
It's obviously.
so I just uploaded the table.
Oh.
I would recommend you like print it out or store it somewhere quick for convenience sake. If you want to use a table for quizzes, I'd have it printed out. After we get out of this unit, no longer testing if you can take an integral, so you're going to be allowed to use technology or the table for every problem. Right, so obviously same rule for the unit 1 test, unless the problem says to use technology, you're not going to be allowed to. Right, but like I said, after that, you're going to be able to use technology to calculate integrals, because I'm not testing your ability to take an integral at that point. I'm testing if you can use an integral and interpret the result.
That would be take home.
So let's go ahead and take a look at some problems that are going to ask us to use a table. There's one very important thing you need to remember when trying to read an integral table. Your integral, your antiderivative, your integrand must match exactly to the formula that's on the table. Very rarely do you have a problem that matches perfectly. Most of the time, you have to do some clever manipulations to get it to match. Either clever uses of substitution, clever uses of what my professor lovingly referred to as dark voodoo math, which is just algebra. All right, things like adding by 0 or multiplying by 1. Completing the square. So let's take a look. We have x over the square root of 1 plus 2x. So let's scroll through. Right? Okay, it's not basic. It's not going to be trigonometric. Definitely not exponential logarithmic. We can ignore hyperbolic. It's not an inverse trig. Doesn't involve a squared plus u squared, right? So we'll just skip that section. Doesn't involve u squared minus a squared. Doesn't involve a squared minus u squared. We'll skip all that. Might involve 2au minus x squared. No, it doesn't. A plus bu, does it involve that? It does. So let's look in this section. Right, we're gonna have a square in the denominator, so it can't be 98, 99, 100, 101, 102, 304. Okay, well, 105 is square root, but not in the denominator. 106. U over the square root of a plus bu. That's a perfect match. The u would be x in this case, right? And b is 2. I'm gonna do is, will it let me copy? It will not. So too lazy to go to my keyboard again. I think I have to do new. Now I'm going to just, of course, you're not going to paste it. Why would you? Now you do. Perfect. Just going to keep that up there for reference. So I have to keep flipping back and forth between screens. So I represent it this way. Equals because of formula 106. So I just write 106 over the equals. Two over 3 times b squared. All right, b is 2. Two x minus 2 times a is 1. Square root of 1 plus 2x plus a constant. Just, oh, right. Don't need the constant, right? Because this was a actual integral. So that's going to go from 0 to 4. Ooh, I can also factor out that 2. That's nice. So that becomes 1/3. X minus 1 times the square root of 1 plus 2x. X equals 0 to 4. Right. This would be the antiderivative, right, of the integrand. Now we're just evaluating that 0 to 4. Okay, so that becomes 3 over 3, which is 1. Square root of 1 plus 8, 9, so that's just 3 minus. Now when x is 0, negative a third times root 1, so plus a third. And we get 10 thirds. Right. Now this is an antiderivative. So again, what we do is come over. Look for a form. No, it wasn't that one. I can tell it's none of these up here, right? These are all u squared minus a squared, u squared plus a squared, right? And then we have, of course, inverse trig and all that. So it's not going to be any of those. Doesn't look like a plus b u. And that was the end. Oh dear. What to do? Let's do some voodoo. So let u be 2x squared. Then what is du? Notice we have an x dx. Right, so I'm going to need a 4, so multiply by a quarter. But we're going to be left with x squared, aren't we? What is x squared in terms of u? One half what? So that remaining x squared becomes u over 2. Factor out the 1/2. We're left with antiderivative of u plus the square root of 1 plus u. Which is formula 105. Again, I'm just going to paste this for reference. This antiderivative from formula 105, we have that 1/8 on the outside. Then it'll be times that antiderivative. Two over 15 times b squared. What is b? Times 3 times b times u. Minus, what is a? And then that's times A plus BU to the 3/2 plus a constant. Four times 15 is 60, right? So that's going to be 1/60 times 3u minus 2 times 1 plus u to the 3/2. Of course, a constant divided by 8 is still a constant, so I'll just leave it as plus c. Replace u, which was 2x squared. How nice is that? We can now factor out a 2. And then it's just a matter of preference. I'm going to leave that as 3/2 power. Right, but you could have also written it this way. Right, they're equivalent. Doesn't matter. What about here? It's not basic, not trig, not exponential, not hyperbolic, not inverse. Does it have a squared plus u squared? No. U squared minus a squared? No. A squared minus u squared? No. 2au minus u squared? No. Right, so it's looks like it's going to be a plus bu again. What do we think? Is the formula currently on screen before I scroll down?
Does it have to be in the exact correct order as well?
No, remember, addition is commutative. So you can switch order of addition.
So could it be 98?
You asking me? You telling me? It is 98. It's already a perfect match. What would A be? And what is B? Again, for reference, let's just go ahead there. That formula says it's going to be 1 over b squared times a plus b times u, which is x, minus a times log absolute value of a, plus b times x, all plus c. And now just simplifying that, we get what? 1 plus x minus log absolute of 1 plus x plus a constant. And there's our antiderivative. Oh, that was nice.
Pretty much tracking except for, can you just choose which one to be A or B? You can just choose.
Look at the form in 98. A is what? Right, A is just that positive 1. Right, B is the coefficient of your variable. Why are you not seeing? There you go. All right, so that's what the question was the order of addition matter? No, because it is commutative, right? So you can always just flip the order and say instead of x plus 1, it's 1 plus x, doesn't matter. 1 over 4x squared plus 25. Why is this one even on there?
dx on the
Well, dx isn't on the denominator here. No idea why this was on here, but we'll go ahead with it anyway. Is it a basic? Is it trig? Exponential? Or logarithmic? We can skip hyperbolic. Inverse trig? A squared plus u squared? U squared minus a squared? A squared minus u squared? 2au minus u squared? A plus bu?
Probably a squared plus e squared.
Going to be very sad puppies. This is a basic integral. This is a calc 1 integral. This is an inverse tangent. We're just going to have to make it fit that way. Remember, you want it to be u squared plus a squared. So what should U be? Makes du 2dx, right? This now becomes a half antiderivative 1 over u squared plus 25 du. Which is now proper form. What is A? Five. Basic integrals, you don't need to tell me what formula number it is, because it's a Calc 1 integral. There's your antiderivative.
How did you get the half out? But u equals,
2x, right?
then why did you take the derivative?
You have to, with u sub.
Or you used u sub?
Yes.
Get it.
Yes. Right, so I'm doing a u substitution here, right? I'm doing a change of variable. So whenever you're doing antiderivatives, if you ever change the variable, you're also gonna have to change the differential, right? We have to go from dx to du. That's why I want to know what du equals.
Nice.
Right. Right. So since it's 2 dx, is there 2 dx in the antiderivative? But 2 is a constant, right? So multiply dx by 2 and the antiderivative, and then multiply your result by 1/2. That has the same effect of just multiplying by 1. See that? Sine cubed 2x times cosine 2x dx. It's definitely not a basic. It's a trigonometric. All right, so let's look through here. Let's see if we can find anything. Uh,
What was the problem?
Sine cubed of 2x times cosine of 2x. Did we see it yet? What one? Not even close. Doesn't have a cosine.
You could probably just use u sub.
I think it looks like one. Three has cosine.
I actually can use u sub here,
U is sine squared.
but I'm not
2x.
going to.
Like three or more.
Oh, wait. Yeah, you can use u sub here, but I'm not going to. I'm going to use the table. It is 41. Right, this one would actually be easier just to do u sub, let u be sine of 2x. But we're gonna use the table to see how we can manipulate everything. But it's not perfect. Right, because this was sine to a power of u times cosine to a power of u, right? Our problem is 2x. So we have to fix that. Let u be 2x. Now, come over. Oh boy, and use one of these. All right, there's actually two of them here. It does not matter which one you use. Down to 1/2. We are now going to be restricted into which one we can use. Sort of. And because of that there. If we use that formula, we're going to wind up with a sine times a secant, which is just hideous. So let's use the top one. Sine to the n minus 1. What is n? Cosine to the m plus 1. What is m? All over n plus m. Then it says it's plus n minus 1 over n plus m.
Is n not great?
2/4. Don't know why I put 1. I'm just going to leave the c to the very end. Since we're doing strictly table, we now have what? Sine of u times cosine of u for the antiderivative, right? Do we see a formula for that? Which one?
36.
36. Bless you.
And
Cosine of a minus b of u. What is a minus b? Oh dear. This is going to be a problem. That face. That didn't work. Bummer. Don't think there's any other. Nope, there's not. Which means you're expected just to recognize this as u sub immediately. For that second antiderivative. Why have you forsaken me, table? And so we just stop there because that's a sad face. Say equals. For an antiderivative, that you can use either sine or cosine as your u. You sine. And derivative of sine is cosine, so you have your cosine u du. So the antiderivative is just 1/2 sine squared. We got 1/8 sine squared minus 1/8 sine squared times cosine squared. Plus a constant. By the way, if you were just to use u sub right off the bat, what would you get? Be 1/8 sine to the 4th of 2x. Place the u. Oh, that doesn't look anything like 1/8 sine to the 4th of 2x. How could we make it 1/8 sine to the 4th 2x?
You probably use the Pythagorean identity for like to get the cosine into sine, and then you simplify.
So right, cosine squared is what?
1 minus sine squared.
That will work. There's an easier way. Isn't there 1/8 sine squared of 2x common? Factor it out. This requires one less step than what you recommended. You'll get the exact same thing, right? You just have to distribute through and then do a cancellation. And you'll get the same thing. That is to show you that the table is not always the solution. U sub right off the bat would have made this less than a minute. Right? Do not become overly dependent on the table or technology. Right? Table for obvious reasons. First, you have to make it fit the proper form. Then you have to actually search for the formula. Technology is only as smart as the person using it. Right? It's not going to know what you want to do. It's just going to know what you put in. You put it in wrong, obviously you're not going to get the right answer. It may take you longer to even type in the problem than it would do to just do it in your head. And as we're going to see when we do analytic geometry at the end, you could put everything in right and the calculator will still give you the wrong answer. Don't know why that one's on there. No idea why that one's on there. Cosine cubed. Well, let's see if we have a formula for cosine cubed. Is it there somewhere? Oh, perfect. Look at that. It's a perfect match. This is a case where actually using the table is faster. Because what you'd have to do by hand is write that as cosine squared times cosine, and then do u sub. Right, cosine squared is 1 minus sine squared. U is sine. Or we can just immediately go like this. And we're done. Tangent to the fifth of 3x. Well, right away, we should see that that 3x is going to be a problem. I'm going to use one of my favorite Greek letters here. Well, that's what I'm going to do, but I'm not going to use U.
Theta.
Psi. Some people refer to that as the devil's pitchfork. Look up Schrodinger's equation. That's why I like psi. It allows us to write this as tangent to the fifth psi d psi. Do we have a tangent to the fifth anywhere? We're gonna have to use the tangent reduction formula. Right, which is number 30. Right, write it. What is n? Right, so tangent reduction formula says 1 over n minus 1 times tangent to the n minus 1 minus the antiderivative tangent to the n minus 2. Do you want to use this formula again? Why? What number? You could use it again. It's perfectly fine. But why when we have the antiderivative tangent cubed already given to us? And so it's 1/2 tangent squared plus log absolute value cosine of psi. And then C on the very outside. Replace psi. And I'm also going to rewrite that log. Negative log of cosine is the same as log of secant. And that would be our antiderivative. Much easier than partial fraction decomposition. A lot easier than trig sub. Any questions? Oh, then you're all about to get a gift.
I originally said to use a table. I realized after I got here, oh. You know, I have to print out a table and give it to you. Not everyone's gonna have access to the files yet. So I've decided that you're allowed to use your calculator for this one. Should be an easy 10 minutes.
You have to provide any proof or just right there. That's right.
And just,
Oh,
but be careful. That means you're either gonna get a 0 or a 10.
okay, so hold on.
Because if you copy it wrong from your calculator, it's wrong. If you put it in wrong, it's wrong.
But the calculator does not have a solve, or not a solve, like a simplified key that I can find. Do you know where that would be on the fire?
It's under algebra.
But it doesn't say anywhere.
Menu, algebra, there's a simplified.
Okay, I'll show you right now. You're like, that's. Nope.
I think it's factor. not
Okay.
Simplified.
Okay. That's there.
Yeah, I'm probably.
We're gonna figure this out.
I think that's their simplified. But it doesn't matter, you don't have to simplify, just give me what the calculator gives you.
Figure it out. I'll accept my zero. Let's peg nicely with the rest of them.
And by the way, if you have a computer, you can use Mathematica. But again, you gotta be careful, because if the answer's wrong, you get no partial credits.
Those two.
So this shouldn't take but what, 3 minutes?